All right, thank you. All right, so welcome everybody. I am Chris Fauerbach. This is I think this is the fourth or fifth time I'm teaching this course. The first couple of semesters, we taught this course using the C++ programming language. Be glad we are not doing that anymore. Last semester, I was able to convince the department to change it to Python. So I think that is a much more applicable programming language for the types of jobs most students coming through this course will look for. Do you need a text? We'll get to that question in a second about the book, so hang tight. I work at Capital One for my full-time job. I am a senior distinguished engineer, which means I'm a senior director level individual contributor, as opposed to a people manager. So I don't have to go through the hassles of people management, or the parts about people management I don't like going through performance management and all that kind of stuff. I absolutely love teaching. Hopefully you'll see that through this class. I love going through career discussions, like how to help someone grow in their career and all that kind of stuff. Those are my absolute favorite things to do. And so this role as a individual contributor is pretty phenomenal. Most companies don't have that, and so it's a lot of fun to take advantage of a company that does have it. And let me start sharing what we're going to go through tonight, if I can find it in my sharing. Oh, there it is. There it is. All right, give me a thumbs up when you can see it. Perfect. All right, now let me get a better view of y'all so I can see you. Check my recording. All right, my recording is going well. Cool. So I use a website called GitHub to host all of my class content. If you can see this URL at the top, this is where you will find all of the material we go through. I'm going to paste it in our chat real quick, if I can find it. I can never find the chat when I'm sharing a screen. It makes life hard. All right, so there's the link. I will update it weekly for the material that we will be going through. And so if you go to the bottom where it says slides, I have week 1 today. We're going to be talking about thinking like a computer. I'll add the link for the PDF version of it as well. And then once I get this uploaded to YouTube, I will add a YouTube link for this content as well. I have a couple of links here that are pretty helpful. The first is a direct link to our syllabus or our class in Canvas, which the homepage is our syllabus, which we're going to go over in a short amount of time. A link to my YouTube account, and I need to update this because I haven't actually made a playlist yet for this class, but I will. Then just some helpful things for when we get into GitHub, when we get into Python programming, and whether we use Docker or not. We'll figure that one out as we go along. So I go through slides like this. And I will frequently pause and ask if there are questions. That's one of my teaching styles. I am super comfortable with silence. So if it seems awkward, that's kind of when I expect someone to ask a question, because there's a concept that might be hard to get or something like that. So our slides will look like this every week. This is week 1. Our goal is to think like a computer. Canvas. Everything is going to be in Canvas for quizzes, exams, homework will all be submitted through Canvas. GitHub.com is a website to share code, to store and share software code, and we will use that heavily for our homeworks. So we'll talk about that more later. And my goal, because we have so many people in this class, is to make all homework submissions graded automatically. So I'm giving myself 2 weeks to figure out how to do that before we have any actual coding homework. But that is the goal, because I don't want to look through 50 people's codes every week. That would take me an eternity. Books. Here's the book question. There are 2 books that will be used for the class. Python Crash Course. Looks like this. Great book. And Python for Data Analysis. Looks like that. The Python Crash Course, there will be homework assignments that are directly taken out of the book. So if you only want to buy one book, buy that book. Or that's a required book. That's a better way of saying it. Look in the VCU bookstore or the VCU. There's some way to get digital copies of some of these things. I don't remember if it was this class or my other class, whether the book was free or not. This one might be free, or maybe that was just last semester. I don't know. So look. The data analysis one, I will not be giving homework directly out of this book, but it's a phenomenal book if you want to buy it. Like, I highly recommend it. Does edition matter? I am using the Python Crash Course 2nd edition. So I don't know. I just got it last semester. So I don't know if there's a 3rd edition out or not, but that's the one I'll be doing. And I don't know the content of edition and of any other edition if it's the same or close. Who is the author of Python with Data Analysis? Wes McKinney. They are linked directly in our syllabus. Both available on Amazon. Let's look at our syllabus now. So, syllabus. Me, my phone number, feel free to call, feel free to text, whatever. I'm flexible. If you need one-on-one time, email me and we'll set something up. I always stay after class until the last person leaves. And so if that ends up being 10:30, that happens, and I'm totally cool with that. I am here for you. That's why they pay me the big bucks. They don't pay me the big bucks. That's why they pay me the big bucks to be here, is to help you. And like I said, I really do enjoy it. Y'all, is everyone here is a junior or a senior, right? For the most part. Anybody not? If you want to tell me, I don't care. It doesn't matter. But I will treat you like juniors and seniors. If you need help, I will absolutely help you. If you don't ask for help, I can't help you. But I do expect y'all to be able to figure some things out yourself. So if you do get stuck, if you do try something and you just can't get it to work, absolutely ask for help. I'm more than happy to help. But try yourself first. Cool? Don't be like my 16-year-old. Love you. Just kidding. All right. We are doing Python. We will do Python version 3.8. And we'll be using a Python manager or environment manager called Anaconda. We'll go into that more. The normal prerequisite stuff, Info 350. Now my favorite topic for our honor code. I absolutely, like, if you've tuned out, tune in. I absolutely hate sending students to the honor council or whatever they're called. But I will do it in a heartbeat. It is the worst part about this job, but I will do it. I despise cheating. I've brainwashed my children since they were like 3 days old that cheating is not good for anyone. It doesn't help you. It doesn't help the friend you're helping. Cheating is the worst thing. I will give you a 0 in the class. And I wish the school would kick you out, but they don't. But I wish they did. Like, I despise cheating, if you can't tell. So just don't cheat and we're all good. And I think I've sent like 8 students to the honor council, and it's no fun. Textbooks we talked about, but yeah, direct links here to Amazon. Any modern operating system, any regular or recently modern computer will be able to do anything we do here. Windows 10, any version, Mac OS, any version recent. We will heavily use Visual Studio Code to do all of our coding. I found installation instructions for Anaconda for every operating system that you'll probably be using. We don't have to worry about that today, but we will be installing that soon, and these links will be helpful. If we use Docker, which I'm not sure we will, there's a link for Docker as well. We're going to be learning a lot about Python, data structures, files, libraries, databases. Oh, that's where we're going to use Docker. No, we're not. Sorry. It's a new content, and I'm still working through it in my head again. So anyway. And then we'll do some stuff with like RESTful APIs. We'll do some data analysis. We're going to do a lot of cool stuff, I think. There are 2 exams. We have a midterm and a final. I will most likely do a quiz every week. Just telling you that now. Did I update this? Oh, I did update this. Okay, so this is the flow we're going to go into. We're going to spend a couple of weeks not coding. So we're going to take a couple of weeks to figure out how to solve problems. Historically, I realized that the things you learned in Info 350 were not what I thought it was when I first started teaching this class. And so we need to spend a lot of time on how to solve a problem with a computer. And it sounds weird because this is supposed to be an advanced class, but I'll try to make it fun. And once we do that, then we will start actually looking at how to use code. We'll look at how we are going to share code with each other. Well, with me. Then we're going to start actually coding. I don't know if we'll actually do 3 weeks of problem solving, but this is a general outline, right? Then we'll look at the Python language. Then we'll go all through all the actual fun stuff of Python that we're going to learn this semester. There will be a final exam. Canvas, check Canvas. I have a quick grading distribution for programming and quiz or homework and quizzes. About 40% of your grade. Your exams are about 60% of your grade. Then I have a subjectivity on participation. So I use that as I'm going to change your grade if I want to. And then the ultimate disclaimer at the end of the semester, I like data. If everybody gets between a 90 and 100 on all their exams and quizzes, that means I didn't do my job right, but I might still curve it down, which I don't want to do. So I'm probably going to make it harder than it should be. So if you start seeing that bell curve move down into the 60s and 50s and 70s, that's a better way for me to get an actual distribution of what you're learning. So I play with bell curves a lot to see how grades actually line up. I haven't actually had to bell curve down yet, but I talk about it every semester. We will have homework pretty much every week because we only meet once a week. So we'll have homework every week. We'll probably have a quiz every week. And I have this in a slide. All right. Any questions about the syllabus for the stuff I talked about? Like, I haven't talked about grading the homework yet, but I'll get to that. Anybody have any questions?
Yeah, how does Python compare to C++? Because
That's him.
350 didn't really teach us about Python at all, so I've never seen it.
Nope, you will. You'll learn all about it. And I'll talk about that briefly in the slides tonight. You did C# in 350, right? Not C++?
Oh, yeah.
Okay.
Sorry.
Yep, cool. It's closer to C# than it is C++, but it's not really. Good question. Oops, wrong one. All right, that was that. I am going to reiterate. See, I do this a lot. I hate cheating. Don't cheat. Seriously. I find it somehow. I don't know how I find it, but I always do. All right, so a little background. This class was C++. which meant since C++ is what you call a lower level language, as opposed to a lot of abstractions in Python, we had to spend an awful lot of time on how memory was managed, how the software actually ran, and we didn't get to do anything, as I call fun. Like, we didn't get to do anything that you would do in a job after college. And so that was one of the big reasons I wanted to switch this to Python, because even if, going to the actuary comments earlier, or any data analysis, Python is the language that most everyone uses for those challenges these days. C++ is absolutely still used in industry, but it's used for programming hardware or device drivers, which I don't do. Y'all aren't going to do. I mean, maybe you are, but not out of this program. And so Python's going to help you learn more usable concepts quicker. Because of that, the pace of this course is fast. If you miss a week, absolutely watch the videos as soon as you can, because we move very quickly. What determines whether we do Docker or not? Depends on what I feel like teaching. It depends on a lot of things. If we have time at the end, we can talk about how we can package and deploy applications in Docker. We can talk about how we automate deployment of applications using Python and Docker and a whole bunch of technologies, which could be fun. So then how hard is it to get an A if the curve keeps dropping? The curve only drops if I don't do my job well. Right? If you think about a bell curve, if our bell curve starts with one person at a 90, one person at 100, and bell curve between there, I didn't do my job right. But that's not a valid distribution for the results of a class. This is how the real world works too. I go by how I do performance management, right? Just because you do your job doesn't mean you're in the top bucket for performance management. You have to do better than others. So I like bell curves. That's kind of life, and so I think it applies really well for grading. Docker is absolutely used all over the place at Capital One. All right, what is Python? So Python is an interpreted, object-oriented, high-level programming language with dynamic semantics, etc., etc. So we're going to look at a little bit of code in a couple of slides, not to learn the code, but to show you the difference between a couple of different programming languages. Python is heavily based on modules and packages. If we're looking down that fourth sentence, paragraph, whatever, there are packages in the Python ecosystem to do anything, everything, anything, both. It's just a matter of finding the right package and using it in your code. And we're going to talk heavily about that. And the standard distribution or the standard library for Python solves the majority of problems that you ever need to write a program about. Then there's a whole bunch of stuff about why we're not doing Java and why we're doing Python. Java is a phenomenal programming language as well. It is used heavily everywhere. What Java is really good for is building user applications or like APIs or interacting with databases, that kind of thing, which Python does really well as well. But Python is simpler. It's easier to use. It's easier to get things done really quickly, as you'll learn in this class. I'm not going to talk about the powerful polymorphic whatever stuff in there that they're talking about. Totally copy and pasted this stuff from the internet. I do that a lot. I should have cited where I got it from, but it was years ago. Python code is 3 to 5 times shorter. Awesome. All right. So Python 3.8, I already talked about most of this stuff. Python 3.8 is what we will be using. GitHub.com is where we will be creating accounts and sharing code. Don't do that while we're talking. I have explicit instructions at the end of class on how to set up your GitHub account. I have to think about automation of grading, and therefore I need reusable patterns for account names and all that kind of stuff. And so, anyway, I talked about all this stuff already. I get ahead of myself. I talked about all this. This is straight out of the syllabus where your Anaconda installations are. If you feel like downloading Anaconda Navigator and installing it, cool. You are absolutely welcome to. But we're not going to do that until a couple of weeks from now in class. Visual Studio Code is different than Visual Studio. So if you do go to like the Visual Studio website, don't download the full Visual Studio, download Visual Studio Code. We're going to be working with Python through both Anaconda and Visual Studio Code. You will be writing your code in Visual Studio Code. Yeah, so the question, will we be talking about other quotes navigators outside of Anaconda? I know there are others. So we can absolutely talk about other environment managers or virtual environment managers for Python. That's the kind of thing where I can quick survey it, or if y'all like are super interested in other virtual environment managers for Python, then we can do it more. But I think a quick survey of other options is going to be helpful, or might be helpful. All right. This next section, this is where we're actually going to start talking about stuff. So who's with me? Yay. I think for a lot of you, a lot of this is going to be kind of remedial or basic, or not basic, stuff you already know. But bear with me, I'll tell you as we're going through this why I'm going through this explicitly. So what is a computer? An electronic device for storing and processing data, typically in binary form, according to the instructions given to it in a variable program. So computers have instructions and data. Whether that computer is your calculator, whether that computer is your phone or your laptop or a desktop or your $43,000 server, computers come in a lot of different forms. Whether it's in this case, they're talking about variable programs, which means the computer is built for general purposes, like your laptop. If you think about your TI-84 Plus calculator, I would not call it a general purpose computer, right? It's built for graphing. It's built for math formulas. Sure, you can write some, at least when I was in high school, you can write some basic code in it to run programs. But what it's really good at and what it's made for is calculating complex mathematical equations and then graphing them out for you. What we're going to talk about is general purpose computers. So the three things I pulled out of that: storing data, processing data, and instructions on how to process data. There are two types of storage in a general purpose computer typically. You have volatile and non-volatile memory, or storage. Storage is a better word. So volatile memory, as an example, is the RAM inside your computer. So when your program is running, it'll store whatever data it needs in memory or in RAM. RAM stands for random access memory. It's called volatile because if you pull the plug on your computer, what happens? It goes away. Exactly right. That's volatile memory. It is not permanent. In quotes, permanent's not a valid word. But it can be lost very easily. It needs constant electricity to store that memory. Versus non-volatile memory. Have any of y'all ever touched a floppy disk? Just curious. Looking at the picture, I'm like, oh, that's really funny. Yes. Okay, good. What about the bigger one, the 5 1/4? Yeah, that's how I grew up. Okay, cool. So that's a 3.5-inch floppy drive. I think that stored like 1.2 megabytes of memory, something like that. Megabytes. Heard horror stories. Yeah, exactly. There are a lot of problems. But anyway, so whether it's a floppy disk or a CD/DVD or a spinning hard drive or an SSD hard drive or a thumb drive or an SD card, these are non-volatile. Like, oh, I just cleaned up my desk. Mine are all over there. But though, if you unplug a SSD drive, what's written to it doesn't change. It is there. This is where I said, quote, permanently. It can be changed. Over time, you have things like byte rot, where literally things change on a hard drive when they're really not supposed to. But for all intents and purposes, what's stored on them does not change. So those are non-volatile. When we start coding, variables, when your program's running, it's all stored in memory. But when we start writing and reading files, they're typically stored on non-volatile memory or on your hard drive, as an example. Processing. Oh, whoops. I realized I have my last download up showing still, so you can't see everything. I still can't see everything. Whatever. I'll talk through it. So the thing in your computer that does the processing is typically called your CPU, or your central processing unit. This is a small, actually, I'm going to look at I have an Arduino right here. Can I shouldn't ask now. Anyway, this is the thing that does calculations. It deals with data. It deals with instructions. Your CPU, when I was your age, CPUs had one core. Right now we talk about hex core, quad core, 10 core processors or CPUs, but each of those cores is a single processor. And what that processor does is it executes instructions that a programmer tells it to execute. It executes them linearly, meaning it does one instruction, then the next instruction, then the next instruction, as is written in your code. Even if you think it's multi-threading, it's still executing a single code linearly. If you have a hex core processor, you can run 6 different programs linearly at the same time, because each processor runs that program, runs a single program. I think I said all that. And there's more details. When we're looking through this stuff for like quizzes and whatnot, when I copy and paste stuff from Wikipedia or techterms.com, and it has things like the CPU typically has its own ALU, FPU register, and L1 cache, I'm not going to quiz you on that. Because I wouldn't get that right either. And I've been doing this for an awfully long time. But I may say, what does a processor do? It processes instructions, right? That's like, I don't try to make this hard. I don't try to do trick questions or anything like that. Because I want you to learn. I want you to have fun, not be scared of tests. Instructions. This is what we focus on in this class. We are focusing on algorithms. We are focusing on creating applications to get a task done. If that task is make an API call to get data from Spotify, cool, we can do that. If it's take a list of numbers and sort them into descending order, cool, we can do that. Right? That sorting thing is an algorithm. It is a set of steps to complete a task. That's what we're going to be talking about the entire semester. Whether it's how do we analyze 17 million records in a weather data set that we got from the federal government, or whether literally we're gonna make API calls to get music data from Spotify. Those are the tasks that we are going to solve. And in order to solve those tasks or solve those problems, we have to give the computer a bunch of instructions to do that. That's what we're going to be coding. I am a computer scientist. I have an undergraduate degree from James Madison University in computer science. I have a master's degree from Virginia Tech in information technology. I will naturally fall into teaching this like a computer science class sometimes, but I am going to do my best to not teach this class like a computer science class, because I don't think that's what y'all need. Sound fair? If you want to learn it like a computer science class, I got lots of resources for you. Anyway. All right. This is like, I threw this together yesterday. This is a really fun look. So, we were talking about C++ and Python and Java. There are millions of, probably thousands, hundreds of programming languages out there that are used every day in different companies and different industries and different projects, all that kind of stuff. The first programming I ever did was in assembly. Assembly is basically the native instruction set to your CPU. This is literally dealing with registers, which are kind of variables, pointing directly to memory allocation. Like, this is as low level as it gets. And this is what it looks like. I found the same program written in 3 different languages to make this point. So adding 2 numbers. So I'm not going to quiz you on like assembly language, but this is fun. So like we are putting the number 14 on a register. You only have like 2 registers. It's really weird. Now we're putting 10 on another register. We're adding those 2 numbers on the register. This isn't really that hard of a program to read, but anyway, this is how we add 2 numbers and print it out. Could you imagine doing that every day? And this is like the most basic of languages that you can do. Anyway, so I think that's kind of fun. But it's like, what, 20 lines of code? Doing the same thing in C. I'm trying to see if this is C or C++. That include should tell me. I think this is C. But here I'm adding 2 numbers and I'm putting them in a variable. I have numbers, variables, printing stuff, getting user input, adding the 2 numbers together and printing out the numbers. So that's essentially the equivalent in C. There's our Python. I know it doesn't do exactly the same thing. It doesn't get the user input and stuff, but it really wouldn't change it all that much. So that's adding 2 numbers in Python. So I like Python. I told you earlier, I'm a senior distinguished engineer. There are, I think, 15 of us in the company. We have over 10,000 associates in technology. And there's a group of us that did a debate a couple of weeks ago, or months ago now, on our favorite programming languages. And we had it with Java, Python, Go, and Kotlin. I was obviously a proponent of Python, and this was basically the meat of my argument was that it's just easy. You can do it quickly. So I love Python. It's my favorite. I've been professionally coding in Python for 10 years now, something like that. All right, so now we're going to start looking at problem solving. Anybody super bored yet? Need me to tell more stories? I won't get up and dance. That's later. All right, cool. Here's a problem that we're going to deal with. Your roommate has invented a really cool robot. Yes, a real robot that does things at your command. I'm reading if you can't tell. This robot is super smart and is instructed by interacting with a human voice. No programming required. The robot can understand simple instructions. Grab something, turn something, squeeze, punch, lift, all kinds of commands. If I wanted to tell the robot to do a jumping jack, I would do something like this. Start with your hands at your side. So start visualizing this as I'm saying it. For me, coming up with solving an algorithm, I visualize it in my head. Like I don't know why, but that helps me figure things out. So start with your hands at your side and your feet together. Then jump up and spread your legs until your feet are 18 inches apart while raising your arms to the side until they're at a 45-degree angle to your shoulders. Reverse the motion to starting point, then repeat 10 times. That's not good enough. Like if I actually had a robot, there's some ambiguous statements in there. But it's thinking through the steps to do a jumping jack. Does that make sense? Weird example. Yeah, but that's okay. All right. We're going to make peanut butter and jelly sandwiches. So either using like notes or notepad or a pencil and paper or whatever. We're going to take like 5 minutes. I know I say 10, but we're going to take 5 minutes. I need you all, every single one of you, because I'm going to randomly pick on some of you. I might make Andrew do it. I'm going to randomly pick on some of you to read your instructions for making a peanut butter and jelly sandwich. I have 7:42 on my clock. We're coming back at 7:47. And I want you to write down your instructions on how to make a peanut butter and jelly sandwich. And I legitimately will call on some people.
So is this in relation to the robot or just
no,
yourself?
No, whatever. Doesn't matter. Just write down detailed instructions on how to make a peanut butter and jelly sandwich.
Gotcha.
Because then your classmates are going to mock it. They're going to pick at it. They're going to have fun making fun of it. And it's okay. This should be fun. So don't get embarrassed. Don't get mad. One thing of note, like I said, I record these and get them on YouTube. I don't show y'all's faces, and I don't share your names on there. If you ask a question, your voice probably comes through, but it's not identifiable. Just an FYI. Andrew, is it within your job description to randomly pick a name for me?
I can.
Please do.
Okay. Sanea.
No last name, please.
I can't pronounce it.
Understood.
This is Nana. Hi.
Hello. Let's give it a shot.
I don't really eat peanut butter sandwich, but I'll try.
Oh, you're missing. No.
Yeah. So I will spread peanut butter on the bread and put jelly over the peanut butter and put two bread together. I don't know. I never make peanut butter, so.
Okay. Anyone?
That's how we make peanut butter.
That is a very abstract way of making a peanut butter and jelly sandwich. Yes.
Okay.
But I have questions.
Okay.
How do you spread the peanut butter?
We put peanut butter on the bread. We take peanut butter to spoon. We use spoon and put peanut butter on bread.
How do you spread the jelly?
Same way.
Same spoon or different spoon?
Different spoon
Which side of the bread?
in the middle.
And when you put the other piece of bread on it, does it go on the dry side or the side with the peanut butter and jelly?
Over the peanut butter jelly.
I mean, I knew the answers to the questions. I'm like, that's the we got to start thinking about those levels of detail, right? When if we were making this a for our robot kind of thing, I think you got to be more detailed, right? Good, all good. Like I said, this is totally meant to be fun. Want to pick somebody else? Now I got to edit my audio. Jonathan, you got one?
Yeah, just I just read it.
That exactly. Just read it.
All right. So I said grab 2 pieces of bread from the bag of bread or whatever.
You wrote down or whatever?
Huh?
You
No,
wrote.
no. I said grab from the loaf of bread, but
That's perfect.
yeah. And then I said to save time, I said because I just assumed that we're gonna have peanut butter and jelly in the same jar. Yeah, I said grab the peanut butter and jelly jar, grab the knife from the handle, stick the knife inside the jar, and grab some of the contents. Spread it on one of the breads. Repeat steps 3 to 5 from the for the other piece of bread. Lay the pieces of bread with the contents facing each other.
I've never bought that peanut butter and jelly mixed, but I do know it exists.
It's delicious.
Anyone have any comments? I liked the by the handle part for the knife. That was helpful.
You have me thinking about robots, and so I was thinking more spatially, as in go to the pantry, pick up a bag of bread, take it to the counter, that kind of
Perfect. Why don't you read yours?
Excellent. All right, go to pantry, open door, grab that bread and peanut butter, take to counter, drop on counter, go to refrigerator, open door, select jelly, close door, take to counter, go to silverware drawer, open drawer, select knife, close drawer, go to counter, take 2 slices of bread from bag, place on counter, open jar of peanut butter, insert knife, smear peanut butter on bread, open jar of jelly, insert knife, smear jelly on bread, place slice 1 of bread on top of slice 2, cut sandwich in half with knife, eat.
I like it.
I like the eat part.
Oh, me too. I love peanut butter and jelly.
For breakfast this morning, so minds think alike.
Yep. I did what was it called? The Ragnar Relay down at Pocahontas State Park a couple years ago. That was like the first time in years I'd had a peanut butter and jelly sandwich, and it just rekindled my love for peanut butter and jelly sandwiches. Anyway, so that was fun. Thank you guys. I really appreciate it. I'm not going to obviously make everybody read, but I think just from a couple of those examples, we can see the different ways we approach the same problem. Some of us naturally think very, very step-by-step explicitly for a robot. Some of us, think about, what do I do when I make a peanut butter and jelly sandwich? And so couple of lessons in there. I'm totally making this up on the spot, but looking at what we're going to do in this semester, a lot of our problems have 15 easy different ways of solving them. There's very rarely one way of solving a problem, and that's okay. Second, there are steps we can take to figure out how to break down the problems we have. Now, when we talk about computers and programming, we have to be extremely explicit. You can't tell a computer, hey, add these two numbers together. You have to write code to have a number and a variable, another number and a variable, add the two numbers together using the correct syntax, those kind of things. We have to learn a language, but we also have to learn how to solve these problems. And so let's talk about how we solve these problems. When I threw this in my semester, or in last semester, I found it in my notes. I did this in week 9. The reason I did it in week 9, because it took me 8 weeks to realize that my students were having a hard time figuring out how to solve problems. They understood the programming language. They understood how to make a for loop. They understood how to make variables and make functions and pass data to and from a function, but they didn't know how to solve a problem. So that's what I want to talk about today. Without coding, we're literally not going to code for a while, because this is the core of software development, if you will, because there are hundreds of programming languages we can learn. But once we learn the constructs that are common in all the languages, it's just a matter of finding the right syntax. Syntax is the easy part, unless you're doing C++, then syntax sucks. But in Java, in C#, in Python, in Go, syntax is the easy part. It's how do you break down your problem and solve it. So Info 351 is yes. And just to be fair though, I used to go straight into syntax as well. And so I'm experimenting this semester with talking about this up front so we don't have to do it later, and so y'all don't have to get really crappy grades on the first bunch of quizzes and stuff until I realize, oh wait, we're having problems solving problems. Yes, I said that right. So this article, I did get permission from the author of this article to use it as the basis for this lesson. So if you want to read the full article, it's linked, please do. But we will go through Chris's summarized version of it. So he broke it down to 5 steps. Understand and analyze the problem. So if you don't know what peanut butter is, you can't make a peanut butter and jelly sandwich. Right? So you have to figure out the things you don't know, or make sure you really understand what's going on. Right? I like Nutella. I don't like peanut butter. Well, figure out what I do too. You got to figure out the problem. When it comes to software, we think about inputs and outputs, or inputs and examples. So when we're adding 2 numbers, what do the numbers look like? When we're reading a text file, what's the format of the text file? What does each data element mean in this spreadsheet? So we have to understand what the data inputs mean and why we need them. Then the hardest part is breaking down the problem. So if I said to you, take a list of numbers and put them in numerical order, right? You could look at a list of numbers and in your head you say that goes first, that goes second, that goes third. But figuring out how to do that in software is very different than doing it in your head. So that's breaking down the problem, is taking the steps, or figuring out, even before you code, figuring out the steps to solve the problem you're trying to solve. Now, over the whole semester, we're going to look at different ways of solving the same problem. We're going to have a week where we talk about 4 different ways of sorting a list of numbers. End result, always the same. But there are 4 different valid reasons we would do 4 different algorithms for sorting numbers. So the way I like to think about this part is, as we learn how to code, as we learn how to solve problems, we're putting tools in our tool belt. Once you learn how to solve how to sort a list of data, that's a new tool in your tool belt. You can then take that piece of sorting data and apply it to a different problem. But now you already know that part, so that part's easy. So when we break these things down, we're going to talk about common patterns. We're going to talk about data structures. We're going to talk about why we use different data structures and all that kind of stuff. Then we can code. Once we understand everything, look at our data, know how we're going to solve the problem, then we can write the code to solve the problem. Then the last step here is look back and learn more. You write software 3 times. Whenever you write any piece of software, you write it 3 times. The first time you write software, you get it to work. The second time you write software, you clean it up. Third time you write software, you simplify it. It's a weird thing. Every single time you write software. Okay. Oh, I totally jumped ahead of myself. Understand, analyze the problem. Read it 2 more times. Do you know what it's saying? Do you need more information? This is one of my favorites. The programmer got stuck in the shower because the instructions on the shampoo bottle said lather, rinse, repeat. Why did I get stuck in the shower? Anybody?
Instructions are to repeat.
Yeah.
No ending.
Exactly. This is an infinite loop. This loop never ends. Lather, rinse, repeat. Okay. Lather, rinse, repeat. Okay. I just think it's funny. That's programming humor. Sample inputs and outputs. We are going to be looking at a website called HackerRank a lot. Because there are a million different challenges on there for coding. It's actually really cool. People talk about using HackerRank or LeetCode or these different websites to get ready for coding challenges on job interviews. I think they're just fun, so I like to go solve these problems. But what's really good about it is, we'll see in a little bit, is how they lay out these problems for us to understand. So we'll talk about that. When we write software, so these algorithms are things like sort a list of numbers. And so if we have a list with 3 numbers in it, that's a very simple example. If I take 3 numbers, 5, 4, 3, and sort it, it should come out 3, 4, 5. Cool. That's a simple example. You can visualize it. You can program to it. You can test it. And then you can put a list of 3,000 numbers to your algorithm. I can't visualize sorting 3,000 elements in my head, but I can visualize sorting 3 of them. So once you code it, your code should be able to handle bigger and more complex inputs. Another very common or best practice in software is handling your edge cases. So imagine we write a function that returns that takes in a parameter of a list and returns a sorted list. We have to think about, well, what happens if that function doesn't get anything sent to it? Or what if there are no items in the list? So these edge cases are things we need to test in our code to finalize our applications or our programs. It's called input validation or boundary testing or all these kind of things. Invalid input's the same thing. If you're sorting a list of numbers, what happens if you send in a list of strings? This is where, breaking down the problem, this is where I start my mental map of what is happening. So when I'm sorting numbers, I have a flow in my head of looking at an element, then the next element, and then just kind of drawing through, getting data here, passing it to here, or doing some process. This is where I start really thinking about how it flows together. And this is where we start thinking about when we get into like programming functions and libraries and all that kind of stuff. How do we break this down into reusable code so we do have building blocks that we're putting together to solve a problem instead of solving the whole problem fresh every time? Then we code. That's the easy part. Once you figure everything out, coding's really the easiest part. Okay. HackerRank is my favorite. So we're going to look at a couple of these. Let's see. We're at 8:05. Let's do a quick 5-minute break and come back at 8:10. That'll let everybody stretch your legs because this is a long class, like 2 hours and 40 minutes. I never go 2 hours and 40 minutes, but it's a really long class. So let's take a 5-minute break. HackerRank. So we will be using this a lot for practice. The way I like to do things is go over material and then go to HackerRank for like the last half hour or 45 minutes or so just to work through some of these problems. And so HackerRank's website has a 14. I can't get to the top of my window. Come on. 14-day free trial. Does VCU cover whatever the membership cost is? I think it's free. I've never paid for it. Is there a cost? But it's usually me doing stuff through it. So, yeah, but we'll figure out if there is a cost later, and I hope there's not. Might have to find an alternative. So, here's an example. Simple array sum. Given an array is a list. Hopefully everybody knows what an array is in general computing terms. Not necessarily how to do it in Python, but I assume and hope in C# you know what an array is, right? Just to have the mental picture of what an array is. Can you find the sum of its elements? So in this example, they give you specific inputs and outputs to your application. But for our problem, we're trying to take an array of integers and print the sum of the array's elements as a single integer. So here's our sample. So this is what I was saying is our simple example. We have 1, 2, 3, 4, 10, and 11. And the output would be 1 plus 2 plus 3 plus 4 plus 10 plus 11. And I guess the output is 31. So we print the sum of the array's elements. So can y'all see my whiteboard at all? Probably not very well, right? Let's see, what can I do about that? Let's see if I can draw big enough. No, you can't read that, can you? Yeah, maybe. I just wrote the numbers 1, 2, 3, 4 up there. The idea is I have a list of numbers or an array of numbers. So without writing code, using terms that sound like they might be instructions for a computer program, how would you add up a list of numbers? So going through our steps, analyze and understand the problem. Anyone not analyzed and understand what this problem is? I have a list of numbers and I need to sum them. Anybody want to volunteer and say, ooh, here, let me make up some instructions on how to tell my computer or my robot how to add a list of numbers?
Would you define an array first? Are we still using arrays?
We're not coding. Nope. So I don't want you to say, use a for loop or set a counter variable to blah, 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 anything like that. Just what I would say is something like, I would add each number to the next number, or I would look at each element or look at each number in my list and keep a running total, or those kind of things. That's kind of like an abstract way of solving this problem. So this example is super simple, right? Let's move to the next one. Diagonal difference. What? Given a square matrix of size n times n by n, calculate the absolute difference between the sum of its diagonals. Now that sounds more significantly harder, right? So I need to take some time analyzing this challenge. Given a square matrix of size n times n. Okay, n by n. So I have a square of numbers. I really wish I could get my camera closer to my wall. Let me see if I can do that. Hello. Is that closer? Can you see that? Okay, cool. My monitor is now right in my face, so this is kind of awkward. Okay, so I have a matrix of n by n. In my case, n is 3, because it's a 3 by 3 matrix. Calculate the absolute difference between the sums of its diagonals. Okay. I probably could annotate on Zoom. Let me try that on the next one. So this is math. Everybody with me? Now I'm thinking in math terms. I'm not thinking in, it may look like variables in code, but it's I'm going math, X and Y. Okay, so the absolute difference between the sums of its diagonals. So the absolute value of diagonal 1 minus diagonal 2. Right? Absolute difference between the sum of its diagonals. That's a sum, and that's a sum. So diagonal 1 and diagonal 2. Whoop. There we go, diagonal 2. So I add those numbers, subtract that from that, and then take the absolute value. Right? Okay. So you see how I'm breaking down this problem to figure out the things I have to do. Now I'll try annotating in Zoom. Bear with me. Annotate. Draw a square. Hey, look. There's one square. This is a really weird way of making a matrix, but close enough? 1, 2, 3, 1, 2, 3. Close enough. Okay. So my steps. Calculate sum. Diagonal 1. Calculate sum. Diagonal 2. Subtract diag 2 from diagonal 1. Absolute value that. Okay. I know my general steps. When I come to programming, now, which part of this is hard?
Getting the diagonal.
Uh-huh. Getting the diagonals. So let's break that part down. Because the other parts are easy, right? Assuming subtracting is easy in a programming language. Calculating the absolute value is easy. Those two things are easy. So let's think about then how we would calculate a diagonal. How do we do that? Use normal words. Anyone?
I guess it would be the first element of the first row, the second element of the second row, third element of the third row, and then so on and so forth.
Until
N.
or you until what did you say?
I said N, but maybe.
Nope, you said it perfectly. I heard end, but
Okay.
yes, I was looking for N. Perfect. Okay, cool. So that's easy. Huh. No, give me that one. There we go. That's how I do it. Okay, so that's diagonal 1, right? What about diagonal 2? Using words, not programming.
So the first element of the third row plus this element of row and the third element of the first row.
Okay, second element of second row, third element of first row. Good. Now, I forget which book it is. I have a book. 1 second. The Art of Computer Programming by Donald Knuth. I don't know if the K is pronounced or not. There's a famous quote about this book, and it's the reason I bought it. And I actually think it's in the preface or something like that. And I'm going to try to find it. I go on tangents every now and then, so bear with me. There's a valid reason I'm talking about this. Anyway, the quote-ish, it won't be exact because it's not written down like I thought it was. A long time ago, I don't know if it was 10, 20 years ago, Bill Gates said something about, if anyone can read and understand this book and explain it to me, I will hire them on the spot. Like, this is I haven't read it. I think I got through chapter 1. It is a theoretical computer science book. But what I like about it, and the reason I'm talking about it is, there is a language like math that is programming language agnostic. It talks about steps, it talks about loops, it talks about variables without being tied to C or C++ or anything. And so now, since you have programmed, what are some programming-esque words to accomplish the first one? You don't have to name variables except n. We have n that we can use as a variable. but like, what would I want to tell my program now on how to solve this problem?
Select.
Say again?
Select. Is that what we're looking for? So select the first element.
No, that's. I realize I'm being vague and not like giving you any good examples or good words. So you're not wrong. What I'm looking for like is starting at 0. Pick. We can use. This is a XY grid, right? We can do Cartesian plane kind of like X0, Y0, whatever.
Are you looking for more of like the nth element of the nth row, and then I guess
Just
n plus 1 element?
stuff like that, yeah, but not n because n is a defined variable. Index is a perfect word. Height and width, x and y, those kind of things. I'm going to move my stuff around. Those are our overall steps. There's our diagonals. So if we think about diagonal 1, I think diagonal 1 is more straightforward. Give me a color. It's different. Give me the blue. So something like counting from 0 to n. Use counter as XY coordinate. Get data at that index. And keep a running total. No, keep a running total is not good. Add to a running total. Something like that. N is okay. I don't know. That feels decent. Describing it kind of like that. How do we do this one? This one is going to feel more code-like because we have to do some math in it. Counting from 0 to n. I'll do the same thing. Use counter as x and n minus counter as y. Get data, blah, blah, blah.
Is that what would allow you to go backwards?
Well, that's true. That's how it was said. So yeah, counting to match the description down from n to 0. Use counter as y x. Does that feel right? Moving up the row. See, this is a visualization. So first part of this, counting from max to 0. So max in this case is 3. Well, and again, we won't talk about zeros versus ones for counting, but anyway. I will change that to 1 though, just to not confuse. N is max. So if I start at max, that's the bottom row. If I'm using that for Y, right? Y is our vertical, X is our horizontal. Max Y would be the bottom row, and N minus counter would be the lower, counter would be, yeah, so we would start in the lower left. Right? And is that what we want to do? That's what we want to do. So that, now we're going lower left. Cool. So next time, if we're counting down, in this case, N would start at 3. This time our counter would now move down to 2. So Y becomes 2, and our X becomes max of 3 minus 2 for 1. That's not totally right. But that puts us in the right direction. N minus counter, counter 2 minus. I'm confusing myself, but this is a general set of steps. So let's see, do I actually have this? I want to see if I have this HackerRank open. Oh, those annotations need to go away now. Okay, cool. So y'all can see HackerRank now, right? Oh, it's not letting me scroll. Why not? Oh, because I'm still annotating. Here we go. So there's a whole bunch of different practice things you can do. I pulled this from the practicing here. Simple array sum, diagonal difference. So the cool thing here is how we do this. So there we go. Has anyone seen Python code? Has anyone seen Python code? Yeah, okay. I am going to solve this problem, but I don't want you to get hung up on the code. I want you to look at the logic, I think. So following my steps, here's where input and output matters, right? So same problem, I understand. Output format, it wants me to return a number. But it's coming into me as an array, which is interesting. So I don't know how this data structure works yet. So I need to understand my inputs. So this isn't going to solve the problem, but the first thing I'm going to do is print my variable so I can see what the heck I'm doing. Oh, perfect. So I'm just going to run my code and see what happens. So my printout, here we go. Okay, so it's giving me an array of arrays, but the first array there is the sample input, is that first row of numbers. So this is my 0, 0 is my 11, 0, 1, XY, X, yeah. 1, 0, 2, 0, yeah. 0, 0, 1, 0, 2, 0. 1, 0. So let's make more sense of this. Anyone familiar with loop, or everyone's familiar with looping, right? So if I write a loop, it'll make sense. And I'll write it in a non-Pythonic way so you can understand it better. So I am going to start with I need a couple variables to do this how I think I want to do it. So I just need a row counter. Actually, I need my row counter. X, Y, 0. So I'm going to get my array I'm looking at. First array is array row counter. So when I run this, I should get a, whoops. Sorry, my Zoom stuff is popping up over me. Okay. Looks like I have that data. So that's cool. I want to make this pretty simple though. How do I do this? I know what I'm doing. X, Y, I. Oh, okay. It's a square, so I'm going to get we had a variable n, so I want my n to be the length of my array. And that should be 3. Just make sure that's 3. So actually I think my row counter is my y. I'm just trying to print out the arrays. Array syntax in Python is just like most other things. You can get an element from the index. Whoops, I didn't mean to submit that. So on HackerRank, when you submit your code, it runs it through a bunch of tests that it doesn't tell you what those tests are. This is how I'm planning on doing your homework as well. So it didn't work, and that's fine. I didn't expect it to work. But I wanted to see, oh, it didn't show my output either. Come on now. Why didn't that run? Oh. Infinite loop. There's no plus plus. Now I'm just incrementing my y. Okay, my length is 3. Good, good. I'm trying to print out this to make it look like a grid. Making sure I can access the correct variables when I think I'm accessing them. And this is turning into way more Python than I expected to show you, so I'm sorry for that. One, 2, 1, 0. That's not what I expected. Oh, wait, yes it is. Because I didn't get my X. Now that's what I expect. So 0, 0 should be 11. 0, 0 is 11. X, I'm printing X and then Y, right? X and then Y. So then I should see 11, 2, 4. 11, 2, 4. Perfect. Then I should see 4, 5, 6. 4, 2, 0, 4, 5, 6. So now I'm looping through this matrix using an x and a y variable like I think I should. To really affirm that, I'm going to print it out like an actual matrix. That didn't print it out like a matrix. All right. Oh, because that goes there. So when I'm going across my row, I don't want to print a new line character at the end. I want to do that when I'm done the row. I'll break down the code for you in a second. But I'm not going to quiz you on any code after tonight, so I don't expect you to retain. There we go. 11, 2, 4, 4, 5, 6, 10, 8, negative 12. All that to make sure I got my x and y coordinates correct. So now I know what I'm thinking of as x and y. I have to tell the program is backwards. That's just the way the data is set up. So that's kind of confusing, but good enough for now? Okay, good enough for now. So now let's go to what we thought for our algorithm. So we want to get diagonal 1. We'll start it at 0 because we want to keep a running total. And too bad I took away my annotations because now I don't see what I did. But I started at effectively 0, 0 and went to the lower right-hand corner, right? So let's make a while x is less than the length. I'm just going to use the variable x, but I'm going to set y as x because for this one, y and x was the same. And we used the index to be 0, 0, 1, 1, 2, 2, etc. So I need to get the value at that location equals my array. They had to be backwards from how I think about it. Although really, I could use one variable, but that's okay. We'll make it explicit this time. Just to make sure I'm going to print that value. And then I'm going to add that value to my running total. All right, before I run this, let's look back at our output. What should be diagonal 1? Starting 11, going to negative 12. What should the answer be? I'm testing your math now. 4. I think it should be 4 as well. So I'm going to run it, make sure I get 4. Now, notice I'm running my code a lot. I'm testing every little change. I'm not writing it all and then testing it. I'm testing it as I'm running it. In this case, to figure out the problem, to figure out the format, to make sure my algorithm or our algorithm is working correctly. There we go. So, I don't know what the heck is all this 11 for. What did I do wrong? I never incremented my x. I just did another infinite loop. That's why it took so long. Okay, I got 4 for diagonal 1. Now, since we're using variables like the length of our array as n, it doesn't matter to me how big this is. It could be a 1 by 1 matrix. It could be a 300 by 300 matrix. I'm writing my code dynamically so it can be of any size. So now the harder one, whoops, I think was diagonal 2. So we'll do another variable for diagonal 2. We'll make sure our x and y's, just clear them out. We'll start them all over. All right, so for this one, we wanted to go to the lower right-hand corner. So instead of counting from 0 to n, the length, we're going to go backwards, right? And that's really the y value. So really, the y is, what do we have a variable for our length? Or our size? N, right? Now programming stuff, I'm going to do n minus 1, and you'll see why soon. So we'll start at n minus 1. So while n is greater than or equal to 0. So I want to go the top to the bottom. Whoops, and that's not right. Y. And this one little change, I'm going to verify it. Y equals y. And then so I don't do an infinite loop, y plus equals 1. I'm pausing to see if anyone catches my error. Y is starting big and goes smaller. But what did I do in my code? I must go down. I incremented. You're right. I incremented by 1. Just to be explicit, this is the same as that. It's a little shortcut. What I really want to do is y minus equals 1 to be the same as y equals y minus 1. Because I want to count down, as we said in our algorithm declaration. So let's run that. So I should see y is 2, y is 1, y is 0. Y is 2, y is 1, y is 0. Okay, so far so good. If I've lost you, I'll give you a chance to ask questions in about 3 minutes, because we're so close. How do I get my x value? I just realized that I wrote it wrong in our write-up. Our x coordinate is the same as our y. Always. Because I'm going in a straight line, corner to corner. So it should also be 2, 1, 0. Right? So if we look at our, where did I print our matrix? Here's our matrix. I'm starting at the far bottom right. So y is 2. First row, y is 0. So y is 2 and x is 2. Y is 1, x is 1. That's why I got confused when I was trying to picture our write-up. So they should be the same. So then the rest should be pretty easy. So I'm going to do exactly what I did up here. Copy. And paste. But it's our second diagonal. And I want to print that out. The backlights on my keyboard aren't working, so I have to look down at them. Diagonal 2. So what should be the value? Oh wait. Nope. I totally messed up again. If they're the same, we're adding the same together, whether we're going up or down. My bad. I was right the first time. So what is x? X is not the same as y, because now we're going bottom left to top right. So we know, what do we know? When y is the max, or n minus 1, x will be the minimum, or 0. So can anyone come up with some math there? If we have x, or if we have y as our row, n is our max, x is, this is algebra. Anthony, yes, x should be 1, 2, 3. In programming, we always count from 0, so really it's 0, 1, 2, but yep. Although I do think C# is 1 based in your arrays, but I don't know for sure. In Python, in C, in Java, and whatnot, we always count from 0. Is it n minus y? N is 3. Y would start it. So again, this is a whole offset 1. Really, n minus 1 minus y. So think about our grid. Let's see if I can draw this shapey again. Draw. Ooh, what is that? Whoa, no, don't do that. Undo. I can tell I'm losing some of y'all. So we'll stop this in a minute. Max, max, xy. 0, max. So to get the x coordinate, we're going to have max minus y. Max is n minus 1. All right, let's stop. Oh, crap, what did I do? All right, so x equals n minus 1 minus y. Diagonal 2 is 19. Does that feel right? 10, 5, 4. That's right. I'm forgetting that the challenge here is not to code this, but to walk through the example. So I'll do the rest of it really easily. Here I have to return a function. I have to return the absolute value of diagonal 1 minus diagonal 2. Something like that. Cool. It worked. Then just to show you the HackerRank submit, we will submit it and it will run it against 10 test cases in this case. That one's taking a long time, so it was a very big variable or a big matrix, and it passed. Cool. So not the code part, but breaking down the problem part. Any questions about what we did, why we did it the way we did, all that stuff?
I have a question about the very last thing that you did.
Mm-hmm.
I didn't understand how you got n minus 1 minus y.
I'm trying to think if I want to answer that yet. Not because I don't want to answer that, but I n minus 1. N was because we count from 0 and we don't count from 1. So like upper left-hand corner in the grid is not 1, 1. Or yeah, it's not 1, 1. It's 0, 0. It's a 3 by 3 matrix, but the maximum, the bottom right-hand corner, is not 3, 3. It's not x, y, 3, 3. It's 2, 2. So the n minus 1 was to get the maximum number, which in this case was 2. From there, I subtracted my y value, which was 2 in this case, to get 0 for my x coordinate. When y is 1, I subtract from my max value, which is still 2. I subtract the 1 to get 1 for my x value. When y is 0, max is still 2. So I subtract 0 from 2 to get 2, to get the upper right-hand corner. I think I said that wrong. But did that kind of, maybe a little bit? Okay. We're learning a lot about arrays in this course. We will use arrays a lot. In Python, they're called lists, but we'll talk about that when we talk about actual Python. But yes, we will use arrays and lists and all kinds of fun data structures. All right, so I had a third one. I'm trying to remember what the third one was, and we may not look at it. Oh yeah. So when we look at HackerRank, or when we look at these challenges or these assignments, some of them are going to have things like this. Constraints. In this case, n, whatever n means, I haven't read it yet, is always greater than or equal to 2 and always less than or equal to 10 to the 5th power. That's to tell you that there's a big range of numbers that you could deal with. K is always greater than or equal to 0, less than n, bill, I, etc., etc. Then function-y stuff. Y'all are smarter than me when it comes to math stuff, I'm sure, so you might know what that actually means. But so here's another problem. Two friends, Anna and Brian, are deciding how to split the bill at dinner. Each will only pay for the items they consume. Makes sense. Brian gets to check and calculates Anna's portion. You must determine if his calculation is correct. For each example, assume the bill has the following prices. Bill 246. So Anna declines to eat item K, which is, so this is where we have to start really breaking down, understanding the problem and breaking it down. The first time I started looking at problems like this, I said, holy crap, I don't get it. But that's where you look at your inputs. You say 4, 1, which, going back to K's and inputs. So I have 3 lines of inputs, 4, 1, then 4 things, and then the number. So reading this, going back to this. So bill is an array. So 246, that's probably this array of numbers. We're not going to solve this one, but again, I'm just going through the steps. Anna declines to eat item K. Okay, so we have a K. So what is our K? Input format. Oh, input format. The first line contains 2 N and K. Okay, so whatever they meant, now I have an N and a K value. The number of items ordered and the zero-based index of items that Anna did not eat. So Anna did not eat those. The second line contains N space separated integer bill where, okay, so that's the bill. Third line contains integer B, the amount of money that Brian charged Anna. So there are 4 items in the bill. Anna did not eat number 1. So on a zero base, so here are the 4 items. Our total bill would be $24, adding those 4 things together. Anna did not eat number 1, which would be 10. So the bill should be 14. So the challenge is saying if Brian did not overcharge Anna, print bon appetit. Otherwise, print the difference. Something like that. So we would break that down, find those steps, calculate the total, find the stuff she didn't eat, compare it to what he charged her. So that's how we break down problems. When we get to this, we will be in Python world, and we should be able to make some sense of it. But that's how we start to tackle these kind of things we're talking about. And that is our slides and our content for the evening. I'm sorry I kept it 9. I didn't intend to do that. Any questions on that so far? This will not be an easy course. I'm telling you that now. I know it's an elective, but it's a hard set of material. So I am forewarning you. All right, you have homework. This is going to be the easiest homework of the entire semester if you do it right. But the way I do homework. So today is Tuesday. We have class Tuesdays. Therefore, our homework will always be due by midnight the next Monday. Basically to give you the full week to do it the night and do the night before class starts. Easy enough? Cool. Everything, for the most part, will be done in GitHub. GitHub timestamps everything you do. So I will always have that as my definitive, what time did you submit your code? If you are a second late and up to a week, 7 days after it's due. So if it's due next Monday, if you turn it in Tuesday at midnight morning, whatever time that actually is, 00 hours, until the following Monday at midnight, 11:59, you can still get credit, but you cannot get more than 50% credit. So if it's late by a second and up to a week. If it's after a week, you can't get any credit. Don't ask, because you won't get it. But the way I'll do that is I will grade it as normal, then divide it by 2. That is your grade if you're late. So just don't be late. So yeah, so it's due next Monday night. So for this week, go to GitHub, github.com, create an account using your VCU email address, please. And I always forget, are y'all email addresses vcu.edu or are they like mymail.vcu.edu? The second?
It's both.
But
Either it depends for what.
do they? Oh.
I have some accounts that are my mail and some is just VCU.edu.
VCU.edu just gets routed to my mail, so I'll say start out with a my mail account.
Okay.
Start like base account.
Okay. Well, and that's why I put in this formatting for your GitHub account name anyway. So use your VCU email account, whether you use VCU.edu or the MyMail one. I don't think it's going to matter. But I want this format. Super important. VCU hyphen whatever your name VCU is. So mine is CH Fauerbach. If yours is D Jones 73984, use that. So VCU hyphen whatever that's called.
Quick question, Professor.
Yes, sir.
Not to break your algorithm, but I already have a GitHub account tied to my VCU address.
Oh, dang it. Email to me.
Okay. I'm going to see if I can do anything as far as renaming
Nope.
it or
Don't worry about it.
repo.
Don't worry about it. Yeah, this is the account. So the way this is going to work for our assignments, this may be Greek until we learn GitHub. I am going to put out a repository of code that is based on your name. So every week, I have to automate this. Otherwise, I'll be grading 50 things every week, and I just don't have time to do that, right? So I will end up creating a repository on my account for you. You will do what's called forking that repository, which means you take a copy of it to your repository under this account. And when you're done, you'll do what's called a pull request. You don't have to know this stuff tonight, but you'll basically push your code back to me. And when you push that code back to me, that's when it'll get automatically graded. If I do that right, you'll get real-time feedback on if your homework worked or not. I won't have to look at it unless there's a problem. And it'll either work or it won't work. I have to figure out how to grade that, like if it doesn't totally work, but I'll figure that out by the time we do this. So if you already have a GitHub account, that's fine, I think. Just email it to me. Again, you don't have to know any of that GitHub terminology yet. We will talk about that at length later. But github.com, make an account. I will put an assignment on Canvas. Take your, this URL and put it into your assignment in Canvas. Actually, that's where you could just don't email me, just put your repository in there. Thumbs up. This is why I love the cameras. I can see some thumbs up. Awesome. Well, that is the material for the evening. Like I said earlier, I am here until the last one of y'all leaves. If you have any questions or concerns or thoughts, or you want to talk about life, whatever, I'm here until you leave. So goodbye if you leave.
Okay, so I noticed in